Good morning everyone. Myself Sriharsha Susarla. For the course project of Embedded Systems, I have chosen to design the project called the lie detector. Within just $50 of expense, I was able to differentiate Mr. Truth from Mr. Liar among my people. Let me clear a common misnomer many people have about lie detectors. These are not devices which deliberately tell you that if a person is lying or if he is saying the truth, but instead, based upon biofeedback, that is, based upon the responses for particular stimuli given to a person, these devices will be able to give you data so that you will be able to judge based upon the anomalies if the particular person under test is telling the truth or he is lying. So basically, this is based on human intuition or human intervention at the endpoint. For this to happen, to make this possible, I have made use of the Arduino UNO board that comes with the Edmega 328 microcontroller. Going into the detail of my project, let us know what is the principle behind the working of this device, what are the results I have achieved, and how it works. The lie detector I have designed consists of 4 subsystems. The first one is the galvanic skin response meter. It is used to measure variations in the skin resistance of the test subject. And second comes the audio preamplifier. It measures the changes in voice pitch, tone, and frequency of the user. And then the third one is the plethysmograph or the pulse rate meter. It is used to indicate the blood flow rate with the help of an infrared sensor. And then the fourth one is the breath rate meter. It measures the temperature variations in the human breath using a thermistor. So, using these 4 sensing mechanisms, I was able to successfully gather sufficient data to judge whether a person is saying the truth or if he is lying. Coming to the implementation of the GSR meter, the first subsystem, I have loaded the code using the Arduino board software. I have connected the board and uploaded the code onto the board, and then I have used the processing software, which is an open source one. We get the code to plot the graph using the processing software. We just need to copy and paste it in the processing interface, and changing the resistances. This is how we exactly plot the varying resistances from the GSR meter. To distinctly note the variations, I have used a potentiometer with the same skin resistance range of 1 kilo ohms to 10 kilo ohms as that of a human resistance range, so that I can more distinctly plot the values appropriately. The second subsystem is the audio preamplifier, where we amplify the audio signal to get a better resolution while plotting the graph. This is how I connected it. The input is to the first pin, and the power supply and ground are connected appropriately on the breadboard. And when I make these sounds, I get the appropriate audio output. And I have used 2 sounds with a lower note and a higher note of my pitch, and the output results are as follows. I have loaded the graph code once again, and this is how the output has appeared at first. And you can see the small peaks when I make the lower and higher tone frequency sounds. You see the disturbances over there. So that is how I could plot the variations in my frequency, tone and frequency and pitch of my voice. Plethysmograph works on the principle that the amount of transmitted IR light through a subject's finger is a function of blood flow in the finger. When the heart pumps, there is an influx of blood into the tip of the finger. This leads to a decrease in the light received by the IR sensor, which can be measured. Heart rate is a key component in the polygraph, since under certain stressful conditions, the subject's heart rate will increase. A measurement is acquired by having the subject place his finger between the elements and remain reasonably still. The breathing rate meter has a similar design to that of the plethysmograph, except that in this case we use a thermistor as our sensor in case of an IR transmitter. The thermistor is placed near the subject's mouth, probably using a face mask, such that upon exhaling the temperature increases, and upon inhaling the temperature decreases back to its original value. The circuit given amplifies the signal 100 times and biases it using the 2 IN 4001 diodes, and in the test I've noticed some clipping on the upper rail, but as it is, we could tell when a breath has occurred, so I did not pursue the problem further.
As far as the results are concerned, the galvanic skin response and audio preamplifier have been plotted and function to achieve the set objectives perfectly. But in case of the plethysmograph and the breath rate meter, they are functional, but they do not show enough efficiency in plotting the graphs. I'm yet to see what the problem is for both of them to plot the graphs, because they're functioning well when I tried with the voltmeter, with the multimeter, but when I try to plot the graphs, this seems to be a problem.